Hello everyone and welcome back to lesson 4 of grade 11 physics. Now, in the previous lesson, we talked about velocity, speed and their differences, okay? And we learned that velocity is a vector quantity and speed is a scalar quantity. A vector quantity has both magnitude and direction. Scalar quantity has only magnitude, okay? And then we also learned about displacement. And we learned for displacement to happen, the position of an object should change, otherwise there will be no displacement. We also learned that for velocity to happen, the displacement of the object also should happen, okay? So if the object does not displace, okay, if it doesn't change its position, it means we're gonna have zero velocity, okay? And then we talked about speed. Speed was a scalar quantity. It only has magnitude. Okay, now in today's video, we'll be talking about acceleration. Now, most people mistake acceleration for velocity, okay? They think that it's the same, okay? They think these two concepts are the same, but they're actually quite different, okay? Now, for acceleration, guys, we use the symbol of a, small a, okay, and then we have this equation, delta v divided by delta t, okay? Now, what does this mean? Let's learn the definition of acceleration from the equation. By the way, this is average, okay? So average acceleration. Let's learn the definition from the equation. Okay, you can easily get the definition from the equation. It is, so we can say acceleration is the change of velocity over time. Okay, change of velocity over a period of time or a time interval. It doesn't matter. Okay, so as you can see, we can get the definition from the equation very easily. Now, what unit do we use? What unit do we have for acceleration? So as you remember, the unit for velocity was meter per second, and then time we have here, time was measured in second. So the unit of acceleration becomes what? Meter per second squared. Okay, so be careful. It's not meter per second, it is meter per second squared. Okay, this is the unit of acceleration. Okay. Now guys, let's look at the definition better and we can get more notes on that. It says, the rate at which velocity changes over time. We already learned that. An object, this is really important, accelerates if its speed, direction, or both change. Now, you learned three things. Okay, you learned that acceleration happens if its velocity changes, or its speed changes, or both change. Okay, so acceleration happens only when velocity is changing or if the direction is changing. Let me give you an example. Let's say you are driving, okay, and you want to increase the velocity of the car. Let's say you go from 50 kilometers per hour to 80 kilometers per hour. Did you change the velocity? Yes, you went from 50 kilometers per hour to 80 kilometers per hour. So acceleration happened. Okay? Let me give you another example. Let's say you suddenly face a traffic jam. Okay, or you suddenly see a traffic and it's red. You have to brake. Okay, you slow down the car, let's say from 80 kilometers to 30 to 20 and then to 10. Now, did you slow down the car? Yes. Did you change the velocity? Yes. So did acceleration happen? Yes. So it doesn't matter if the speed is going up or it's going down. If it's going up, acceleration happens. If it's going down, it means acceleration still happens. What if what if you go with 50 kilometers per hour and you don't change your speed? Okay, let's say for 30 minutes you are going like this. It means there is no acceleration, careful. So acceleration happens only when velocity changes or direction. Now, let's say this time you don't brake, okay, but you do what? You don't hit the brake, but this time you turn the car. With what? With the steering wheel. Now, did you change direction? Yes. Did acceleration take place? Yes. Why? Because you changed the direction. So let me remind you, acceleration can happen in 3 cases. If velocity changes, it doesn't matter if the speed of the object is going up or it's going down, okay? If direction changes, let's say you have a car and you do this with the steering wheel, you turn to right or you turn to left, okay? You change the direction. If direction changes, it means acceleration also changes, careful. And both can change at the same time. You can hit the brake of a car and then you can turn the wheel to the right or to the left, okay? That is how acceleration happens, okay? Now, we have some notes you should know. By the way, we can write acceleration in a different form, okay? We can say average acceleration is equal to, look at here, we have what? We have delta, okay? Both. Whenever you have delta, it means it is a change in something. Here we have change in velocity, and then down we have what? Change in time, okay? So we're gonna say V final minus V initial divided by what? T final minus T initial. Okay. ما عندك بكرديش شرح بكين بو قطابياني كإنجليزيان ببي بيوزنية باشا. Acceleration واتا the rate, okay, at which velocity changes over time. باشا velocity معناها لسري لخوارش كات معناها كواتا قوراني velocity لا يكي كاده باشا. We use what unit? We use meter per second squared. أوي unity acceleration باشا. acceleration لسه حالة دارو دادات. أول ليرة highlight مانكر أجر speed بجورة بون من السيارة اللي دخليته باولين 50 كيلومتر ليك ساعة دا روي. لبر سيارة كي دقيني 6 كيلومتر ليك ساعة دا 7 كيلومتر ليك ساعة دا 8 كيلومتر ليك ساعة دا. أو قراني خيرية وادكات تصير روبدا وادكات acceleration روبدات باشا. يعنيش دكري أراستا direction. You can change the direction. دتواني أراستا سيارة كي بقوري بتي بالسكان. وأنا السكان كي أولدكي دتي بيتكي ولا أراست سكان كي أولدكي لو حالة تجدا acceleration روبدا أقدر دكري هردو الشيء بيكو بي direction speed. دكري بيلا استابني والسكانكش اللي بكي بومنا كنت بيز دكي ولا راس خو يكسر بيز ناكي عبرين اللي صدروي خو يكسر بيز ناكي نا استاب دغري او جاوب دو السكانكي ده سورينيا كاتا لو حالة الشان ده acceleration رود ده اقدر كاتا سي كيس معناه speed changes غوراني speed direction يعني غوراني direction غوراني اراستا يعنيش هردوش يعني اقدر we have some notes that you should know them when you are dealing with acceleration. Basha. Acceleration happens due to change in velocity and direction. Okay? It can be both and it can be one of them. If an object starts from rest, it is at rest. It's not moving. Basha. Nazule. If it starts to move, okay, it means the pencil started moving from 0 meter per second. Okay, so this is gonna be what? This is gonna be V initial, which is equal to 0. Careful. If we say an object starts from rest, we're gonna say V initial or V1 is equal to 0. Careful. Okay, which means what? Which means the object is speeding up. بون السيارة اللي دخلي سيارة بيدا كيتو سيارة كلا 0 كيلومتر دروا جاري تازة بيت كردية وردو دا بنزين دا دقري دبي 3 كيلومتر 20 كيلومتر سي أو بيدا لين سي speeding up. Okay, v initial is equal to 0. If an object comes to rest ما بس معناتها أجر object بوستي it means v final is gonna be 0. Let's say you want to stop the car, you're gonna hit the brake and then you're gonna bring down the velocity of the car to 0 kilometers per hour. Okay, this means that v final was 0. Okay, we're gonna learn that in questions better. Okay, here, this means that slowing down. Okay, if v final is equal to 0, it means the object is slowing down. If v initial is equal to 0, it means the object is speeding up. If an object can accelerate even if its speed is constant. Okay, it says what? An object can accelerate even if its speed is constant as long as its direction is changing. Circular motion. Okay, direction also can change acceleration. Okay, now if an object moves with a constant speed, okay, let's say an object moves with a constant speed, okay, it means v final is equal to v initial. بابلين سيارك معناه لسي كيلومتر ليك ساعة دروا. Okay, v final and v initial are equal to 0. Okay, so here acceleration is gonna be, you say, 0. Careful. Why? Because we said for acceleration to happen, the velocity should change. The car is going with the same velocity. How can it have acceleration? Okay, so careful. If the speed is constant, it means acceleration is 0. Careful. Positive acceleration means object is going, the speed of the object is increasing or speeding up. Negative acceleration, we have another name for it, which is called deceleration. It means object is slowing down. Okay. Now we have these notes too. If an object is, I think we forgot one point here. Yeah, acceleration is a vector quantity. It has both magnitude and direction. أقدر تاوكو يستا سي شتمان هبوا كvector quantity بي. Displacement, velocity and acceleration, they are all vector quantities. أقدر برسم what is a vector quantity? A vector quantity has both magnitude and direction. What is a scalar quantity? It only has magnitude. Basha. So acceleration is a vector quantity. It has both magnitude and direction. Okay, let's take a look at these notes. It says acceleration is positive and v initial is positive, or velocity. Okay, it means that the car is speeding up. Okay, if the acceleration is positive and velocity is positive, it means the object is speeding up. What if both are negative? Don't get tricked by this negative. Negative does not always mean that the object is slowing down. Just because it's negative, it doesn't mean something is decreasing or like this. Okay, it's basically just the direction. Maybe the object is going to the left, or maybe the object is going to south. Okay, that is why we give it negative. Okay, so if acceleration is negative and velocity is negative, it means speeding up. Kawata, if the signs are the same, positive, positive, negative, negative, it means the object is speeding up. Okay, what if they're different? If it's negative, positive, positive, negative, it means the object is slowing down. Okay, careful. Okay, let's solve a question here. It says a shuttle bus slows down with an average acceleration of negative 1.8 meter per second squared. Okay, so we have acceleration, which is equal to, acceleration is equal to negative 1.8 meter per second squared. Okay, it says what? How long does it take? Tamashayka. How long? What comes to your mind? How long? It means delta t. باشا delta t أو لا يخد بنود بنوسة. How long means delta t. So delta t is equal to what? It takes the bus to slow down from 9 meter per second to a complete stop. Look, it says what? Complete stop. It means what? Okay, let's go back to the note. Look, it says if an object comes to a rest, let it complete stop. It means v final becomes 0. Careful. So v final becomes 0 meter per second. Okay, and then this one becomes what? This one becomes v initial. V initial is equal to 9 meter per second. Find delta t. Okay, you memorized average acceleration. So average acceleration is equal to delta v divided by delta t. Basha. Always remind yourself that the units should be consistent. Okay, we said the unit of acceleration is meter per second squared. Okay, we have meter here, we have second. We have meter here, we have second. We have meter here, we have second. The units are consistent. Okay, if you want to find delta t, just change its place with acceleration. Okay, so delta t is gonna be what? Delta v divided by average acceleration. Okay, now this is gonna be what? This is gonna be v final minus v initial. Okay, divided by what? Average acceleration. This is gonna be what? 0 meter per second subtracted by negative 1.8 divided by what? By, subtracted by 9 meter per second divided by what? By negative 1.8. This is going to be what? Negative 9 divided by negative 1.8. These two cancel. We have 5 seconds. Okay, we have 5 seconds. Some of you might ask why acceleration here is negative. Okay, because the bus is slowing down. It says slowing down. If it slows down, it means we have a negative acceleration. Okay, as the shuttle bus comes to a sudden stop, okay, keep it in your mind. To avoid hitting a dock, it accelerates uniformly at negative 4.1 meter per second squared. Okay, so we have acceleration which is equal to negative 4.1 meter squared. Okay, as it slows down from 9 meter per second to 0 meter per second. حركاتك from to تبيني تمشاوي كده. Let's see, from 9 to 0 meter per second. واتا يكم يندبيت v initial دوم يندبيت v final. باشا, and we already know that because it says to a sudden stop. We learned if an object comes to a rest, it means v final is 0. Okay, so this one becomes v initial. V initial is equal to 9 meter per second, and then v final is equal to what? 0 meter per second. What is the time needed to for the bus to stop? Okay, so delta t is equal to what? Again, average acceleration is equal to delta v divided by delta t. Switch their places. We have delta t, which is equal to what? Okay, we have v final minus v initial divided by average acceleration. Okay, so this is gonna be what? 0 subtracted by negative 4.1 divided by what? Divided by 9 divided by what? Negative 4.1. Okay, so this is going to be negative 9 divided by negative 4.1. Let's divide it. The two negatives cancel. So 9 divided by 4.1, we have 2.19 seconds. Okay. Question 2, it says a car traveling at 7 meters per second accelerate uniformly at 2.5 meter per second squared. Okay, let's leave this here because we don't know if it's v final or v initial. Okay, but it's going to be clear once we read the question. Acceleration is equal to what? Is equal to 2.5 meter per second squared. Okay, to reach a speed of 12 meter per second. Basha. Then let's see. A car traveling at 7 meter per second accelerates uniformly to reach a speed of 12 meter per second. So it went from 7 to 12. It's obvious. So 7 becomes v initial, 7 meter per second. And then v final is going to be what? 12 meter per second. How long? Again, we have how long does it take? So delta t is equal to what? Delta t is equal to what? Okay. Again, average acceleration is equal to what? Is equal to delta v divided by delta t. We want what? We want time, so switch the places. Delta t is gonna be what? V final minus v initial divided by average acceleration. Okay, this is gonna be what? V final, we have 12 meter per second minus 7 divided by what? Divided by 2.5. Okay, let's calculate that. 2.5 divided, so we have 2 seconds. Careful. Okay, 2 seconds. That is the time it takes for this acceleration to occur. Okay, we have question 3. It says a cyclist reduces his speed. Careful, it says reduces his speed from from 2. The first one becomes v initial, the second one becomes v final. Okay, so v initial is equal to 6.5 meter per second. V final is equal to 0 meter per second with an acceleration of negative 1.2 meters squared. Okay, so we have what? Acceleration, which is equal to negative 1.2 meter per second squared. How long does it take? Again, we have what? Delta t. So delta t is equal to what? Basha. Average acceleration is equal to delta v divided by delta t. Again, we need what? We need time, so change the places. Delta t is gonna be what? It's gonna be delta v, let's make that v final minus v initial, and then divided by what? Average acceleration. Okay, now we have v final, which is equal to what? 0. We have v initial 6.5 divided by what? By negative 1.2. So you have what? Negative 6.5 divided by negative 1.2. Let's divide that. So you have 6.5 divided by 1.2. The negatives cancel as usual, so this is going to be 5.41 seconds. Question 4. The velocity of a bicycle is changed from negative 1.2 meters per second to negative 6.5 meter per second. Look, I told you whenever you have from 2, okay, the first one becomes v initial, the second one becomes v final. Okay, now this becomes v initial, this one becomes v final. Basha. During what? Delta t is equal to what? 25 minutes. Okay, if you want to change minutes to second, just multiply by 60. So 25 multiplied by 60, we have 1500 seconds. Okay, what is acceleration? Average acceleration is equal to what? So this is pretty easy. Average acceleration is equal to v final minus v initial divided by delta t. V final is equal to negative 6.5, okay, subtracted by what? By negative 1.2 divided by what? 1500 seconds. Okay, I think in some questions this 25, in some books this 25 is 5 minutes. It doesn't matter, okay, just a different number. Okay, so we have negative 6.5 subtracted by negative 1.2 and then divided by 1500 seconds. We have what? We have negative 3.53 times 10 to the power of negative 3 meter per second squared. Careful, because it's acceleration. Okay, suppose that the bicycle in item 4, question 5, has an average acceleration of 4.7. So average acceleration is equal to 4.7 times 10 to the power of negative 3. By the way, this one is negative 3. Just a technical mistake. Meter per second. A. How much does its speed change? So delta V is equal to what? After 5 minutes. If delta T is equal to 5 minutes. Okay, 5 multiplied by 60, we have 300 seconds. Okay, now, average acceleration is equal to delta V divided by delta T. What do we need here? We need this guy here. Okay, so multiply these two. Multiply average acceleration by delta T. So delta V is equal to average acceleration multiplied by what? Multiplied by delta T. Okay, now we have average acceleration, which is equal to 4.7 times 10 to the power of negative 3 times time, which is equal to 300 seconds. This is equal to 1.41 meter per second. Okay, that is what? That is delta V. Let's check. Let's make sure. So 4.7 times 10 to the power of negative 3 times 300. Yeah, we have 1.41 meter per second. B, it says what? B, it says if the treadmill's initial speed is 1.7, so V initial is equal to 1.7 meter per second. Okay, what is its final speed? So V final is equal to what? Okay, so here you don't have to use that equation. Okay, very simply we're gonna say what? Delta V is equal to what? V initial minus V final. Do you remember that? Yeah. Okay, we had that in the equation. Okay, do we have delta V? Yes, it's equal to 1.41. So 1.41. Do you have V final? No, we are searching for V final. Minus V initial, which is equal to 1.7. Okay, now to find this, take this to the other side. V final is equal to 1.41 plus 1.7. This is equal to what? 3. I think 13 or 31. Let's check. So 1.47 plus 1.7. We have 3. This one is 41. So 41. We have 1.41 plus 1.7. We have 3.11. Okay, so 3.11 meter per second. Okay, that is what? That is the final result. Okay, this is it for today. In the next video we'll be talking about constant acceleration. Okay, if you can memorize the equations of constant acceleration or uniform acceleration, it will be much better. Okay, you will understand the calculations much better. So until then, see you in the next video.